PHI 308. Study Session 3. The Scientific Enterprise. Introduction. In this lecture, we shall be looking at meaning, features, method, and aims of science. In contemporary discourse, the discipline of science has been viewed broadly under three distinct categories. These are the natural or pure sciences, the applied sciences, and the social sciences. In the strict conventional sense, however, the word science is employed to signify the natural or pure sciences. Science, so described, has certain features. It is objective, it is impersonal, it is specific, and it is public in character. Learning outcomes. At the end of this lecture, you will be able to distinguish between science in the broad or general sense and science in the strict conventional sense. And lastly, identify those features that are the hallmarks of science. Meaning of science. In the Chambers 20th Century Dictionary, science is defined as any systematized, organized, or classified body of knowledge which has been critically tested and is beyond reasonable doubt. The English word science derives originally from the Latin noun scientia, which has its roots in the Latin verb scientia, meaning to know. This broad understanding of science as any body of systematized knowledge makes every academic discipline to count as science. This is the reason Ernesto Grassi, in his The Origin and the Limits of Moral and Natural Sciences, describes such disciplines as history, religion, law, linguistics, and even philosophy as science. Popper, 1963. Robert Morgan, in his Science and Technology for Development, The Role of U.S. Universities, corroborated this view when he describes science as any activity resulting in knowledge and understanding about the world around us. Morgan, 1979, page 18. The foregoing broad conception of science notwithstanding, in contemporary discourse, the discipline of science has been viewed broadly under three distinct categories. These are the natural or pure sciences, the applied sciences, and the social sciences. The natural sciences include astronomy, biology, chemistry, earth sciences, and physics. These sciences study natural phenomena. In other words, they deal with the properties and behavior patterns of natural objects. The applied sciences include architecture, medicine, engineering, and information technology. This branch of science is described by Robert Morgan as an activity resulting in procedures for building and creating things in prototypes and models of products, in gadgets and inventions. The ultimate goal of the applied sciences is to be able to control the course of events and enhance man's comfort and happiness on Earth by inventing more and more technological facilities. The social sciences deal with the behavior and interaction of persons by appealing to our knowledge of the social institutions and the relatively recurrent cultural practices which give meaning to these behavior and interactions in the society. Among the social sciences are economics, sociology, psychology, political science, anthropology, and geography. In the strict conventional sense, however, the word science is employed to signify the natural or pure sciences. It is these understandings of science that inform S.P. Guyet's definition of science as a specific modality of human activity, investment, which consists of producing objective knowledge based on the discovering of laws in the various areas of reality, enabling us to give a rational account and an extremely good anticipation of events and phenomena. Guyet, 1995, page 8. Science, so conceived, has four distinct characteristics associated with it. Aigbodio, 1997, pages 3 to 5. Features of science. 1. Science is specific. By this, we mean that science deals with particular observable or identifiable objects of this terrestrial world. Rather than this, with some abstract general ideas of being. Again, it means that science provides us with information about our world as it actually is. This is the reason the natural sciences are sometimes referred to as exact sciences. 2. Science is public in character. By these, we mean that the techniques and methods, as well as findings and products of sciences, are not understandable only to the select few, but are capable of being communicated and taught to the generality of persons for this reason. The conclusions and knowledge claims in the sciences are not only interpersonally verifiable, but are also open to public scrutiny. 3. Science is impersonal. By this, we mean that science does not involve beliefs or ideals which result from a person's peculiar power of imagination, that science is dispassionate and unprejudiced, and that science does not admit of value judgments or arbitrary preferences, as choices are made strictly in accordance with scientific techniques and methods which are objective in character. 4. Science is objective. By this, we mean that the concepts, laws, and theories of science are drawn from the hard and naked facts about the world of everyday perceptual experience. In other words, the objectivity of science derived from the fact that pure facts form the bedrock of scientific theories and discoveries. In this wise, laws and theories in science are taken as valid irrespective of human expectations, attitudes, and wishes. The above features of science distinguish scientific knowledge from ideologies, beliefs, metaphysics, and religious articles of faith, and they confer on science the power to uncover the truth about the world as it actually is. This is the reason the emphasis today is on science, with the prevailing assumption that every problem, personal and social, as well as natural and technological, should be amenable to solution by the application of the method of science. Ofor, 1999, page 155. It is this present assumption that informs the decision by many other disciplines to employ the scientific method in their investigations. But first, what is the scientific method? The scientific method refers to the general procedures of carrying out research in the natural sciences. It has to do with a set of rules, norms, and criteria governing all the operations and procedures needed to develop a scientific theory and establish a scientific law. As a method of research, the scientific method is said to be identified with a number of procedural stages or steps. Although scholars are not generally unanimous about the exact number of research stages in the scientific method, Ackoff, for example, identifies observation, generalization, and experimentation as the three traditional phases of scientific research. Aigbodio, 1997, page 24. While Hempel suggests a four-stage process of scientific research. Hempel, 1970. Roughly and briefly, we may present the scientific method schematically in this way. 1. Observation of a problem. 2. Formulation of hypothesis. 3. Verification by experience. 4. Confirmation of hypothesis. 5. Formulation of scientific laws. Once a scientific law is formulated, it is then possible to explain and predict future occurrences on the strength of such laws. Aims of science. So far, we have looked at the meaning, features, and the method of science. What then can we consider to be the aim or aims of science, so conceived? In his The Rationality of Scientific Discovering, Nicholas Maxwell affirms that the aim of science is simply to discover more and more facts about the world or about the phenomena under investigation. Whatever the world or phenomena under investigation may turn out to be like. Maxwell, 1974, page 124. Here, science is said to be pursued for its own sake, in order to increase our understanding of the world around us. This view has been criticized on the grounds that it divorces science from the practical needs of human beings who see in science a means of improving their existential condition. Another view is that the aims of science should be conceived in terms of its utilitarian values. From this perspective, Science is not pursued for the sake of the knowledge it gives, but for its economic and technological values or benefits. A third view, which is common to Eastern, is that the ultimate goal of science is to explain the world and its phenomena by establishing certain observed regularities about them, and conceptualizing or expressing such regularities in the form of hypotheses, laws, and theories which would enable us to predict future occurrences. The basic assumption here is that the universe is simple, harmoniously united, orderly, and beautiful in itself, but that the scientists seek how best to understand the world in these terms. Although this view has gained popular acceptance among scholars, it cannot, however, be said to express the complete aim or aims of science, since scientific practices and results are not usually affected by whatever views are held by individual scientists regarding the ultimate goal of science. It is therefore more plausible to consider a more eclectic approach to the question of the aim of science, an approach that will incorporate all the views so far expressed by various scholars on the question of the aim of science. This can be better achieved by looking at what scientists actually do, rather than what some people believe they do. Scientific activities are readily characterized as acts of explaining, understanding, predicting, or describing the occurrences and processes of natural events and phenomena, and where necessary, inventing for the purpose of improving the existential human condition. This is what G.S. Sogolo means when he says that science is both theoretically and practically motivated. Study session summary. In this lecture, we have distinguished between science in the broad sense and science in the strict conventional sense. We examined certain features which are today seen as the hallmark of science, which are that 1. Science is objective, science is impersonal, science is specific, and lastly, science is public in character. We then examined the views of philosophers on what they consider to be the aim or aims of science so conceived, but concluded that each philosopher's view only reflects part of what the aim of science should be, since scientific practices and results are not usually affected by whatever views are held by the individual scientists regarding the ultimate goals of science. We then suggested an eclectic approach that will incorporate the views so far expressed by various scholars on the question of the aim of science. End of study session 3. Thank you for listening.